Hello?
Yeah.
There we go. Oh, fantastic.
They can hear us.
All right, so yeah, my name's Phil Kwong. I'm the founder of 3 Carbon Extractions. 3 Carbon is a extraction research and technology company. And recently, we actually partnered with a licensed dealer here in Canada called Veritas Pharma and their subsidiary Canavert Therapeutics. Through that relationship, I actually formalized a relationship with the Denver, Colorado extraction manufacturers for closed loops, Extraction Tech Solutions. ETS was one of the original closed loops for hydrocarbons, and they kind of led the pathway and forming kind of a journey for hydrocarbons in the United States. Beside me is actually their sales engineer, Swiss, who I've been working with kind of through the past little while. Him and I have kind of developed a framework kind of going into Canada as Canada legalizes extractions and edibles in 2019. Typically right now, we're in an interesting transitional period where flowers and oils are about to be legalized in October of this year, and edibles and derivatives and extractions will be 1 calendar year after. And today, we're gonna be going over the different types of extraction methods, break down some of the fundamentals of concentrates, and then have a little bit of Q&A for the time after. So typically speaking, in the simplest form with extractions, we have a breakdown between the different extracts and concentrates products from solventless, distillates, isolates, and different various forms of solvent-based extracts. With the solventless methods, typically really, there are 2 most common types of solventless methods, and that's rosin and dry sift. Rosin is the process of taking heated plates and pressure and actually taking dried cannabis flower or various forms of hash and squishing it, essentially. And what you're doing is you're taking out the trichome heads and kind of squish them into an oil or a resin. These products typically are consumed mostly by smoking, but also at the same time have kind of grown a popularity for individuals and consumers looking to experiment with concentrated products that aren't actually used by a solvent. The second method of rosin typically used is for cleaning hash. And a lot of these products that you see now on the shelves, like live rosin, are products that have kind of made a real big kind of impact on a lot of people that are kind of moving towards looking for products that they could feel a little bit more trusted about with the kind of misinformation or confusion about solvent-based extracts. The other method of solventless that you've got is dry sift. And dry sift really is the series of using a series of silk screens and sifting the bud back and forth. And what you're doing is you're knocking off the trichome heads and you're basically taking out the contaminants or the impurities, which would be plant matter. These products have a great representation of the cannabis plant. They're beautiful products and kind of like a creme de la creme in a kind of way where it's very connoisseur, but at the same time, they're very difficult to scale. Going down through the transition of extracts and distillates, going into actually distillates is a pretty cool method. And it's kind of like an extraction process in an extraction process, where you can actually get to the distillation process using different various forms of solvent. But typically speaking, for this workshop, we're going to reference to hydrocarbons. So when you actually make distillates, the process about how you get there is with hydrocarbons using a solvent like butane or propane, you actually create a product what's called an oleoresin. And what that is a compound of terpenes and cannabinoids after you've actually run through your closed loop. And in that oleoresin, the next step that you kind of go into is you use a secondary solvent like ethanol to saturate it, and we go into a product called winterization. Winterization is the process of actually removing out the impurities and the plant fats and chlorophylls that you don't actually want. And after you actually lead through that process, what happens is you put it into an explosion-proof freezer, and from there, you can actually filter it out. When you filter it out, what you've got is the starting basis of what's known as an absolute oil. Once you get to this stage, well, the next kind of process that you're going to go through is you evaporate out the ethanol. And how you do that is you use a device called a roto-evaporator. Through this process, what you're doing is you're recovering your ethanol for future use, and you're left what is called a absolute oil. The next steps that you want to get into is decarboxylation. And what that means is you want to break the carboxyl groups. So what you're doing is you're releasing the acid. Because with cannabis, when it grows, it doesn't actually produce THC. It produces what's called THCA, which is an acidic form, which is a non-psychoactive. So when we decarboxylate, what we're doing is we're transitioning the THCA into actual THC, which actually produces psychoactive effects. And when we're making distillates, we want it to be in the THC because distillate is a starting point for various different products, from capsules to tinctures to creating isolates even. Once you actually have your decarboxylated oil, this is when you actually start getting more into the filtration, or sorry, the actual distillation process. So when you're going through this process, you use what is known as two of the most common methods of distillation in the industry, short path or white film. But for this process on the workshop, we're going to reference the short path distillation. So with short path distillation, typically, you go through two different passes. And on the first pass, correct me if I'm wrong, Swiss, on the first pass, what you're doing is you're actually cleaning out the terpenes and the terpenoids and removing those parts out so you can actually isolate out the individual cannabinoids. Once you actually pass through the first cycles, what you're doing is you're being able to get into that transition of isolating the different cannabinoids. Typically speaking, the most common distillates you see are THC distillates and CBD distillates. But commonly, you'll typically find some small trace amounts of other cannabinoids, but what you'll see is you'll see a high percentage of THC or CBD depending on the material that you ran, whether it's dried flower or hemp, and you'll be in the area of around anywhere above 95% pure THC or CBD. These products are cool because it's a starting point. You can create many different types of products from this, from your distillates, your isolates. These are fantastic for actually going into vape pen cartridges. And you can actually do what's known as actually adding another solvent, and this is actually how you create your isolates. So extraction distillates are cool because it's an extraction inside of an extraction process that actually carries itself through. But going more into the solvent-based extracts, these are the parts of the industry that have kind of become the more topic of conversation. With the actual solvent-based extracts, what you've got is you have water as a solvent, you have CO2 as a solvent, ethanol, and most commonly hydrocarbons, which is butane and propane. With water, a lot of the time these are confused with solventless extracts because no petroleum-based solvents like butane or propane were actually used in the process. But water is actually one of the most common universal solvents in almost every single industry. And water as a solvent, it doesn't really bond to cannabis very well. And because it doesn't really bond to cannabis very well, you don't get very high yields. You don't get a lot of retentions of cannabinoids and terpenes. And these products are typically more of on a connoisseur or a smaller scale production level. With ethanol, ethanol is a cool solvent because you can use it in the actual extraction process, or you can actually use it for a variety of different reasons. Like when we're making distillate, it's to kind of purify products, actually take out different impurities. But ethanol is actually fantastic for actually cleaning your equipment as well. But with ethanol extracts, this solvent really does justice when you're actually doing large-scale processing for hemp. Because the way that ethanol actually strips the plant, it actually takes everything with it. So it creates a very crude style oil. And with CO2 products, CO2 is an interesting solvent because it's kind of been deemed kind of the more safe route of extraction, even though every method of extraction has its pros and its cons, and it has its own kind of risks in going through. With CO2, it's an interesting solvent because it comes out at a very high pressure, but it's not explosive. But CO2, these products, because CO2 doesn't actually produce high-yielding products, it doesn't actually retain a lot of cannabinoids and terpenes, and CO2 actually adds a lot of moisture into the extraction process, which can actually create a shelf life on the actual product itself or produce mold. But going into hydrocarbons, there's been a lot of topic of conversation and a lot of controversy about hydrocarbons and whether they're safe, whether they're actually clean and going through. And with hydrocarbons, it's interesting because through all the different solvents, butane and propane actually bond the best to cannabis. They produce the best yields, you get the highest retention of cannabinoids and terpenes, and you actually resemble a really good profile of the plant itself. With hydrocarbons, typically speaking, when you hear butane or propane, you're thinking about probably a can of butane, or you're thinking about a propane tank. These aren't actually the grades of solvent that is used in the extraction process with hydrocarbon extraction. What is used is actually grades of solvent known as instrumental grade or research grade. And what that is the purest form of solvent. And this pure form of solvent is actually used in other industries, from decaffeinating coffee all the way to actually research-based in the different kind of pharmaceutical industries as well. And with hydrocarbon solvents, the most important parts to remember is actually the grade of solvent and the quality of the flower. And I'll let Swizz kind of get more into the technical details, but as a show of hands quickly, how many people smoke joints here? Fantastic. How many of you actually use a lighter to smoke your joints? Great. Just so everybody knows, when you use a lighter to smoke your joint, you're inhaling about 300 parts per million of residual solvents actually coming from the lighter, and these are lighter grade butane. With this, you are consuming more solvent than you'll actually ever consume in the actual concentrated products. So, little fun fact for everybody there.
Thanks, Phil. That was a great opener, too. That was a lot of terms that Phil just went over, and I want to kind of go back and really dive into what all these different solvents mean, why some are better than others, but it's not that one is better than another. The reason hydrocarbons have been a predominant solvent in the cannabis industry recently is their ability to develop a wide product range. So what we do at Extraction Tech when we meet a client is we look at their product as a whole, their end goal processes, and start with selecting the correct solvent for that. And what I mean by that, to elaborate on Phil's point, is you'll see a lot of hydrocarbon processing in the United States and all the legal models. We have systems currently in operation for the point that most of those processors are on the THC side product of the market. And we'll get to hemp and CBD, distillate and isolate here shortly. But what I mean by a wide product range is if you've been into a dispensary or a shop and go to the shelves, you can see there's crumble, wax, shatter, THCA crystallization, a new popular product they're calling sauce now with terpene retained in the THCA, so on and so forth. Those products are all readily available and easy to process and make off using hydrocarbon solvents such as instrument grade butane, isobutane, propane, or ratios those to achieve different goals. Beyond that, the processing times compared to other methods are much faster. So as a producer, that means more flower produced per day, means more extraction produced per day, and there's much less bottlenecking happening. But again, there's always a use for a solvent depending on the situation. For example, in Colorado, there's quite a bit of hemp that grows. There's a lot of hemp processors. Hydrocarbons may not be the best solution for them because they need the ability to run thousands of pounds of material per day, and they're only making one product. So something like ethanol works great for them because ethanol's pro is you can have extremely large batches, extremely large processing loads, but its con is you can really only get one or two products out of it easily without extensive post-processing. But that works out for hemp because most hemp farmers are interested in processing with the end goals being CBD isolate or CBD distillate. So it really comes down to what a client's project really is. Is it going to be hemp? Is it going to be a processor for the THC side of the market? And you've seen hydrocarbons playing a much larger role overall in the THC side of things. And to recap too on solvent quality, that is a common stigma that you'll find throughout the industry. And a reason that was born was in the early days, you had people what we call open blasting, or basically taking a glass or a stainless steel tube, packing it full of cannabis and running some very low quality, lighter butane, like Phil said, through the product and just catching that in a dish underneath. So there's two obvious huge problems with that. Problem one is the quality of that solvent is terrible. To even put quality in the same word as that is embarrassing. That's lighter grade butane, has many other hydrocarbons in it. There's actually not that much butane in a can. There's machine oil, heavy metals. Should never be used for extraction of anything for human consumption. The other issue was these people were not taking any safety measures or safety protocols to make sure they're doing this process safely, because whether it's hydrocarbons, CO2, ethanol, there's dangers in any process. Can they be done safely? Absolutely. They are all over the world right now, but that needs to be considered. So back in these early times, these people would be open blasting in closed rooms with 1,000 cans of lighter butane behind them, and someone would light a cigarette or plug something in, do something in a completely unregulated, unsafe environment, and they would have an explosion. So that put a bad stigma on the industry as a whole when it comes to extraction, specifically hydrocarbons. And we've done a lot of work over the last few years to try to help educate and pull back around to show what it looks like, on a much larger scale in a regulated facility. So with hydrocarbon extraction, first we're using instrument grade solvents, instrument grade or higher, like Phil said. That's not the same kind of propane that you'd throw on your grill to cook burgers with. If that leaks, it makes a rotten egg smell. That's an additive in that propane called mercaptans. That's toxic to humans, should never be used for extraction. So you can see the theme I'm going with here is when we extract with hydrocarbons, we source instrument grade, medical grade, or higher purity solvents, because at the end of the day, we're making products for human consumption. People are smoking these, they're using them for crude, for distillation, for edibles, and solvent purity is extremely important in that regard. Most local areas will have analytical testing labs that you're required to send batch tests of all concentrates to test for potency, all the cannabinoid profile, but more importantly, microbials, heavy metals, toxins, anything to make sure that product coming out to an end consumer is safe for consumption. And I'm sure we'll see that trend happen in Canada as the processing grows. And you want to elaborate a little on that, Phil, too, what you think the coming regulatory regarding analytical testing should be for extractions, or what you think might be absorbed for these LPs in Canada?
Yeah, absolutely. So when we look at Denver and Colorado, which is considered one of the most strict and regulated states and counties for derivatives and processing, when they first legalized, the residual solvent count for them was what's known as parts per million, correct me if I'm wrong, was around 500 parts per million?
I think it might have even been even lower than that.
Oh, even lower.
It's gone up and down significantly. There are states in the U.S. that have 5 part per million requirements, which is extremely, extremely low, but it can be attained through hydrocarbon extraction, especially with a solvent like instrument grade propane. That's become a very beneficial solvent for many reasons. It pulls an excellent terpene cannabinoid range. A high quality product comes from that extraction method, and it's very easy to purge, and this is something we'll get into a little bit, but processing facilities, no matter what the method is, always break down to 2 core parts. You have your actual initial extraction progress, which would be hydrocarbon extraction, ethanol extraction, whatever it is, and the oleoresin, as Phil said, that's created from that process is really a broad spectrum of all of the available things that could be extracted from whichever method. From there, that product's taken to the post-processing side of the lab, which is your second big part of the laboratory. That's where we take that starting extract material and manipulate it with different laboratory equipment to create all of these different products that you see on the shelves, like wax or shatter or THCA crystallization, or even go further down to distillation like Phil was touching on earlier. In that, propane's an effective solvent for these shelf products that don't go to further refinement, especially in areas that require something like a 5 ppm residual mark, because propane in atmosphere will evaporate by itself at minus 43 Celsius. So you can't have liquid propane in atmosphere because its boiling point is so low. Now when you have that contained in concentrate's sticky by nature, so is a lot of the propane going to evaporate right out of it after it comes out of an extractor? Absolutely it will, but some could get stuck in there. So with a minimal amount of heat post-processing, which is something anybody can learn, thousands of people have and do this every day, we can attain under 5 ppm with not much education and guidance. So it's really important to select solvents that, on an ethical level, you're creating a safe product for your customers, but also on a processing guideline. So you want to elaborate too, Phil? I think you'd agree.
Yeah, absolutely. So previously, before I kind of started 3 Carbon and got into where I am, I founded and ran the company called Holistech. And Holistech produced products to the dispensary markets here in Vancouver, locally, and a little bit in Canada. Through that process, we did all of our analytical testing through 2 Health Canada accredited labs. One here local on campus called Anandia Labs, and another one over in Victoria called MB Labs. With Anandia, they are considered and highly regarded as the lead testing lab in Canada working towards North America. And they actually have some of the most sensitive machinery in the entire industry. With testing on their residuals, we came back where we were doing different experiments and different R&D, where right out of the collection vessel, when we had fully just recovered, I actually sent in the product for testing, and it came back at around 200 parts per million. And that was before any post-processing, going into vacuum ovens or anything like that. Once it actually went into the actual oven and we went through the processing to make products like sugar wax or shatter, when it would go back in for testing, it would hit non-detections. But which was cool about Anandia at an early age was they didn't put non-detections ever. So what they would do is they would tell you the exact pinpointed amount of residual solvents going all the way down to 1 parts per million to 1.5, all the way to 0 parts per million, which was cool because after you go down from the million, you start going into parts per billion. But as we all were talking about earlier, when you smoke a joint, you're inhaling more solvent out of your lighter than you are smoking these actual concentrated products. So the analytical testing is huge because the other thing too to always remember is your starting material. So it doesn't matter what method of extraction you're actually using, from solventless, dry sift, rosin, extractions with solvents, it all comes down to the starting material. Because if you have a flower that had mold on it, or it had PM, or something pesticide sprayed on it, whatever, these products or these can actually be transferred into the actual finished product. So it's important to actually remember how your product was growing, where it came from, and make sure that analytical testing was actually done on the flower as well. So coming into legalization here in Canada, we're going to start seeing a lot more analytical testing. There should be a lot more transparency coming into the industry from a whole, which is actually pretty cool because it's interesting from a prohibition point where a lot of companies in Canada have actually followed American models. They've already started submitting their products in for testing. They've actually started using the analytical labs through their MMARs or the ACMPR licenses to actually ensure quality control. And a lot of the time what we see is these products actually are deemed and considered as safe. But at the same time, there's a confusion with it a lot where it's all based off of the actual method of extraction. But what's important is to remember that it always comes back to the actual starting material. So when we look at the legalization of Canada and where it's going, and as Health Canada kind of transition and goes through, it's important to remember that we need to include the analytical testing labs to actually talk about the safety and these products that are actually being produced. So it's not too bad.
Yeah, and something else I wanted to touch on too is laboratory safety. How is this process, we'll start with hydrocarbons and we can look at other methods too, but how is this actually done at scale with employees in a real working facility that's doing 2 shifts, 3 shifts, 1 shift, whatever it is a day, safely? That's a huge concern. That should be your top concern as a producer, is the safety of yourself, your staff, and anyone visiting the facility. So with hydrocarbons, and when we say hydrocarbons, we're referring to instrument grade butane, isobutane, or propane. They're all flammable and explosive. So care needs to be taken in hand when working with these solvents. So what you'll see in the States now that will probably get translated up here is what we call a Class 1 Division 1 environment, which is a National Electric Code standard in the States. And what that is basically the extraction equipment and the operator have to be in a classified room that's free of electricity, has a hazardous ventilation system, and that creates a constant airflow over the equipment so that if there's any leaks, God forbid, that's rare, but anything could happen. If there's a leak, any hydrocarbon vapor escaping the system, that hazardous ventilation system removes it immediately, and there's leak detection installed so that if you get to a certain level of hydrocarbon vapor in that room, alarms will go off to make your staff aware that they need to get out of the room or perform some sort of safety measure to correct the situation. It's very rare these even go off. I've only seen it happen once myself, and it did its job and everything was fine. But these rooms are set to such high standards that it makes the chances of having a combustion extremely small. The reason because of that is it's based off what we call the LEL, or the lower explosive limit. So let's say my extraction room is 10 by 10 by 10, so just a big 10 by 10 by 10 cube. We know based off the cubic footage of that room through a formula how much hydrocarbon vapor could actually make an explosive condition in that room. For example, if I took a cigarette lighter into that size room and just held the thing down without lighting it, drained all of the butane out of it, and then I lit the lighter, nothing would happen. There's not enough hydrocarbon vapor in the room to be combustible. But if I had 50 pounds, 100 pounds, however many pounds of propane vapor in that room, different story, right? So the standards that we run these C1D1 environments by are 20% of the LEL is when these alarms will go off and when the ventilation will kick up at least 600 CFM to mitigate any of that vapor before it has a chance to do anything. And keep in mind that that's at 20% of the LEL. 100% LEL is when a combustion is even possible. So we never let it get past 20%. Is that overkill? It might be a little bit, but safety is the #1 priority in any laboratory. And hydrocarbons have been demonized a little because they're explosive and because they're flammable. But if you look at other methods, they have their own risks. None are safer or more dangerous than each other. It's about your staff's education, the level of their education on the actual equipment itself, and the facilities that the owners have installed to keep them safe in a worst case scenario. If we look at ethanol, it's not considered explosive, but it's extremely flammable. And at large hemp operations that use ethanol, they go through it by the 55-gallon drum. So you could have hundreds of those drums on site. Same thing, there's storage practices, best safe practices, and everyone's working towards GMP for part of that reason too. CO2, same thing. It's not a flammable solvent, it's not explosive, but it operates at 1500 PSI or higher. That's extremely high pressure. If a bolt is loose on a system, you don't want to be on the other side of it. So, I think it's great that the industry should work towards more working together instead of trying to manufacture, demonizing other manufacturer with this method or that, because none of them are really safer or more dangerous. It's more about proper education, and it's sad if people have to suffer at a safety level because of that. So that's really what we try to do at Extraction Tech is through outreach, training, working with local fire marshals, AHJs, authority holding jurisdictions. We really try to drive the safety of not only the engineering of our equipment, but we want our end operators to understand that too.
Yeah, and kind of touching base on safety and manufacturing and kind of the safety of the environment you're in, there's been a lot of conversation about different equipment and picking the right equipment. And lately, there's been a conversation about a lot of kind of build-it-yourself closed loops through a couple of brands that are importing from different parts of the world. But really, one of the biggest reasons why I chose to work with ETS and why I was so interested in their systems was the manufacturing standard and quality. And Swiss, a lot of people don't actually know the standards and quality of of what it takes to actually build one of these machines, and actually the safety and the process that it actually takes to go through. Could you just kind of touch base a little bit on ETS and like the difference of the quality of the machine compared to other ones?
Absolutely. So manufacturing standards for extraction equipment, again, in any method, are extremely important because at the end of the day, all of these systems are holding flammable solvents, very high pressure solvents, and circulating them many, many times over again. So in the States, when we started, it was kind of a gray area. There really were no standards, and our CEO did a very smart thing and went to the fire marshals directly, a third-party mechanical engineering firm directly, to review our equipment, because we were confident in its design, but we wanted a professional engineering firm to have it reviewed to ensure that. That's a standard in the U.S. now. If you sell extraction equipment in the United States, hydrocarbon extraction equipment and some other methods, it's required that it has a third-party full engineering peer review report. So that's a 400-page document of all the math, science, everything that goes into that equipment, and that's submitted to the fire marshals in each state and county directly. I'd imagine something similar will come to Canada, but that, you know, these are the safe practices that need to be held accountable on any method. Beyond that, as far as the equipment itself, I wouldn't recommend anyone gets anything off the internet and tries to build an extractor in your house. If you have, I'm not trying to be a hater. I did it. We've all started somewhere, but don't take the risk. The industry's come so far from that with standards now that there's a much better, safer route to go. So beyond that, besides the build it at home stuff, there's larger manufacturers that for profitability purposes will import lower quality stainless prefabricated from China and other areas. Issue there is they have no traceability in their manufacturing process. So if you don't know if the welds are okay, you don't know who's welding them, you have no batch reports on this lot of steel was used to make these machines, so on and so forth. In our opinion, that's a huge concern, and that's not something in the States they're really enforcing yet, but our equipment is all domestically sourced steel. It's all welded in an ASME code shop, and we have full traceability in the manufacturing process. And I'd like to think part of that, since 2011, is a reason we haven't had a fatality or a vessel rupture or an explosion or anybody hurt on a piece of equipment. And it's hard to say off the top of my head, but I'd say we have nearly probably 650 active units in processing facilities throughout the U.S., Puerto Rico, and hopefully Canada soon. So, you know, when you look at extraction, an unfortunate thing with the cannabis industry is that I've met some of the best people through the cannabis industry, lifelong professional relationships, friendships, but there is also a lot of snake oil, and extraction is no different than the rest. So, you know, if you're interested in extraction, really take the time to do your own research, find the right people to talk to, hold manufacturers accountable for their engineering standards, their equipment standards first before you even start talking about efficiency of this, that, or the other, because if you or your staff doesn't go home at the end of the day, there's no point in the first place. Beyond that too, I'll let Phil go back on the next subject, but we can circle back on any of that too. We're going to do some questions before the end here.
Absolutely. So it's interesting as we kind of wrap up the workshop now and kind of come to an end, and it's like all the things that we see on the shelves today, and Canada is in an interesting transitional period where there's not a lot of consumers questioning the products on the shelves, and there's almost this blind trust of what's deemed as a quality product and what's not a quality product. But at the end of the day, the most important things are, well, unfortunately, dispensaries are going to be stripping their shelves soon, and concentrates in these products are going to be difficult to come across in Canada right now. But during this process, before we lead up to that time, when you are going into a dispensary, when you are speaking to the bud tenders, when you are looking at products, it's important to always remember to be asking for lab results and asking for the quality standards of what the actual processor was able to provide. But both ETS and myself will be here for the rest of the day, and we actually have a machine up at the booth too, if anybody wants to come by and check it out and talk about the actual process of how the machinery works. But with the last little bit of time that we've got here now, we just wanted to open it up to a little bit of Q&A if anyone's got some questions.
Yes, sir. I'm sorry, sir, not to make you repeat yourself, but thank you.
The new kid on the block is vape pens, and with the process of distillation, the result needs to be buffed or made more liquid to go in the vape pens. What are they using for carrier agents? And have you heard of something called popcorn lung, which comes from using a substance that's used in movie theaters to make the popcorn butter more buttery?
Yeah, popcorn lung, I've heard of. I can't speak on it in depth, but it's related to chemical compounds being ingested that are not good, or inhaled for that matter. But in the past, people would use things like propylene glycol, which I would never recommend to use as a cutting agent for distillate or for vape pens. But what a lot of people are using now, which is a great idea because it has more than one benefit, is they're using terpenes to do exactly what you're saying. So, like you said, most vape pens now are made from distillate because distillate is extremely potent and we can dose accurately with it because it's such a high purity. But distillate is like the consistency of cold honey. So if you just try to put it in a vape pen, it locks it up. It's not going to function well at all. And real distillate is odorless and it has zero taste. It's just potent. So how do we create flavor and change the viscosity of a pen or a distillate solution to get it to function in a cartridge? The way we do that mostly now is with terpenes. So terpenes are the aromatic compounds in cannabis. They give strains different effects and different flavors and different smells. Those can be extracted themselves through steam distillation, recovered through hydrocarbon extraction in a cruder form, but they work great as a cutting agent for vape pens because you can have a half gram of distillate to a half gram of terpenes, and the terpenes not only will put flavor back into that cartridge or that pen, but they're like the viscosity of water. They're very fluid. So when you create a solution of terpenes and distillate, it renders the overall product actual viable in a vape pen or a cartridge. So a consumer can actually use it, and furthermore, it'll give flavor or effect back to that cartridge. So there's a lot of places that are big fans of doing analytical tests on their flower. To test for things like Phil said, microbials and the whole panel, but even more so they want to see what ranges of terpenes are in, say, blueberry, for example. They can do several tests on one phenotype of that strain and get an overall average of what the terpene profile is. So they can take that profile and re-simulate that with a distillate to create not only a functioning cartridge, but it's very close to that strain now as well. So that's what we've seen in Colorado and a lot of the other states over the last few years, is using terpene as a cutting agent.
Last question. I've heard of people putting in food flavorings and making it taste like root beer or cotton candy or some other kind of a fun thing. I can't believe that going through the blood-brain barrier has any positive effect. You got anything to say about that?
I can't speak too much on the blood-brain barrier or synthetic flavorings like you're talking about, but most people are not a fan of using synthetic anything to mix back into their cartridges, nor am I. So terpenes have that benefit as well, as you hear these terms a lot. So really, you hear the term cannabis-derived terpenes, and you hear the term synthetic terpenes. Synthetic terpenes are lab-generated versions, which most people want to stay away from, and I don't blame them. But cannabis-derived terpenes can get interesting too, because that could mean one of two things. They're derived directly from a cannabis plant, which if people want to go through steam distillation to get those, that's great. They're very expensive and they're very sought after and they work great. But terpenes are not only in cannabis. In my opinion, it's important that they're organically derived. So, for example, there's a terpene called limonene that has very citrusy flavor. You'll find it in cannabis. You'll also find it in oranges. So, molecule is a molecule. The limonene from the orange is the same limonene from the cannabis. So, you can have organically derived terpenes from much larger sources like oranges or other fruits, natural areas, and use those as well. But it kind of gets fuzzy with people when you say, is it cannabis derived? If it came from an orange, I'm going to say no, because it came from an orange. But is it the exact same compound? Absolutely. What you want to stay away from are synthetic terpenes. D-limonene is synthetically made in bulk, and it's used in pine sol and floor cleaners and a whole plethora of other things. And furthermore, beyond that, the whole point is just to keep it organic and make sure you're giving your end user something quality. And propylene glycol too. Stay away from any of the popcorn lung stuff, like you said.
Can you guys give a ballpark cost for like per gram production of an end product, like a sugar wax or a shatter? I know it will depend on your starting material, but let's say you have good buds, like 20% THC.
Price per gram or overall yield?
Like price, the production price. So if you're starting with a kilo of cannabis and you get out 200 grams of extract. What's the cost for that?
And hydrocarbon extraction, and to make time for any other questions too, if you want to come meet us up at the booth, we can go into further detail. But another benefit of hydrocarbon extraction is the energy consumption, everything it requires to actually operate the equipment is very low. We're talking about 50 amps or under running capacity between an air compressor, a chiller, and a hot water circulator. Other methods, much higher energy cost and much longer processing times. But again, every project is unique. Everything is different. But if you have a project and want to meet up there right after we're done, we can go into more detail and try to get you a tighter answer too.
Are there any other consumable products that you use personally that are extracted with hydrocarbons?
Yeah, so I'm a big fan of distillate pens, which aren't direct.
Not cannabis.
Oh, not. I think everybody in this room does. They've been used in food processing for years. If you ever had a creme brulee, what do you think they cooked the top of your?
Yeah,
your
but
creme
do
brulee?
you, when you buy olive oil, do you buy solvent extracted olive oil or cold press?
I couldn't tell you honestly. My wife does that, but. Yes, sir.
Oh, no, I'm just.
Okay. Any more questions? I think that's it. Thank you, everyone. Again, too, if anyone has any questions or wants to see equipment, what it looks like, how it functions, we have a booth right up in the corner by the door.
Thanks, Mark.
Thank you, everyone, for your time.